good morning or good afternoon, depending on when you're watching this. So today we're going to be talking about even and odd identities. And if you recall back in Unit 1, we talked about even and odd, meaning that odd, there's symmetry about the origin, the paper trick where you turn it 180 degrees, versus even is when you can fold it over the y-axis and it's symmetric that way. Well, if you recall in our last unit with graphing, sine and cosine and all of the trig functions have even and odd as well. So when we're working with this in our simplifying and verifying eventually, we're going to be looking for a negative x within the trig function. So if you see sine of negative x or cotangent of negative x, that's going to be an indicator that we want to come to this section of the formula sheet. So odd identities are the ones that, again, they have symmetry about the origin. And the first one that we will see this happen on is sine of negative x. And all we do is that x that was negative, the negative gets to come out in front. So we pull the negative out. Now, the thing about the trig identities is that if a function is odd, then its reciprocal is also odd. So if sine is odd, that means cosecant. We do the same exact thing. And then there's one more odd function of the 6 trig functions, and that's tangent, and then its reciprocal cotangent. So if you see any of these 4 trig functions with a negative x inside, we just take the negative and pull it out. Now, our even functions are obviously the 2 that remain, which are cosine and secant. And the reason for this is that if you graph cosine, we could flip it or fold it rather over the y-axis, and it would completely lay over top of itself. So in this case, when we see cosine of negative x, instead of pulling the negative out, it's allowed to go poof, which in my class we talk about magic math, where things magically go poof. And in this case, this is a place where you're actually allowed to do it. That's not considered magic math because these 2 functions are even. So let's see what this looks like in practice. So example 1, we have sine of negative x times cotangent of negative x. So I want to take care of the even oddness first. So I'm going to take the negatives out or make them go poof, depending on what the function shows me. So for example 1 here, sine is odd, so the negative comes out in front. And I'll use some parentheses here because cotangent is odd, so the negative also comes out in front. Now that means that in this case, a negative times a negative is a positive, so I don't need those negatives anymore. They cancel each other, and now I just simplify the normal way. So if sine of x times, I'll change cotangent to cosine x over sine x because the sine x's will cancel, and in this case, I'm left with cosine x. For example 2, again, I see that there's this cosine of negative x. In this case, check your sheet if you need to, but cosine is an even function, so when I rewrite this, it goes poof. And over on the other fraction, there was no negative, so we'll just rewrite it as is. So now to simplify this, I've got 2 fractions, not quite a common denominator, so I'm just going to simply multiply the numerator across to each fraction, cross multiply, to create that common denominator. So in the first fraction, it would be 1 minus cosine x, in the middle plus, and then 1 plus cosine x. And then all over the multiplication of those 2 binomials. So what happens when I multiply 1 plus cosine x times 1 minus cosine x? If you need to, pause the video, do FOIL or box on your paper, and then check back in for the correct denominator. If you've FOILed correctly, you should notice that those middle terms will cancel. And in this case, to keep simplifying, in the top, we see we've got a negative and a positive cosine x. So we literally have 2 left over up top. And 1 minus cosine squared x should look familiar. It's not quite on your formula sheet, but it is one of the Pythagorean identities. If we manipulate it, we can change it to sine squared x. And lastly, I can use reciprocal identities and get 2 cosecant squared x, for my final answer. Now you've got 3 practice problems. I want you to pause the video and give those a try, and then come back for an explanation and the answer key to each. So for problem 1, first, again, identifying even versus odd. So with secant, it is the reciprocal of cosine, which is even. So in this case, this first negative x goes poof. So we literally have secant x minus secant x. This one simplifies to just 0. Our second example, we have cosine of negative x, that goes poof, over sine of negative x, that needs to come out in front. In the next set, we have cosine of negative x, again, that goes poof, because it's even, and just a regular sine x. From here, a couple different things that you could do. One way to keep simplifying is to change the cosine x over sine x to cotangents. So we would have negative cotangent x minus another cotangent x. So simply put, we have negative 2 cotangent x for our final answer. And then for our last example in this section, we have a negative cosine x, so we'll change that first. Again, cosine allows it to go poof. And now for Euler box, and this actually is the same as the denominator question we paused earlier. So hopefully you remember that in this case, that's going to be 1 minus cosine squared x, which changes to sine squared x by Pythagorean identity. So at this point, you are going to grab the sunshine and clouds worksheet and try the additional 4 examples, and then you can check your answers on Classroom.